Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Let us start today's class. Today's class we are going to discuss fluid mechanics. Okay, fluid mechanics already many things we have discussed in our previous classes, but the specialty of today's classes today we are going to discuss match uh, some bits, important bits, okay, and their answers, okay, multiple choice questions and their answers we are going to discuss in our class. Definitely this class will be helpful for your assistant engineering as well as assistant executive engineering examination conducted by UPPSC and Telangana State Public Service Commission. Okay, so let us start today's class. Right, so material is ready in front of you. We'll start discussing. Bionic force is the resulting force on a body due to the fluid surrounding it. The resultant force acting on a floating body equal to the volume of liquid displaced, the force necessary to maintain equilibrium of a submerged body. So buoyant force is equal to the volume of liquid displaced. The line of action of the buoyant force acts through the center of gravity of any submerged body, centroid of the volume of any floating body, centroid of the displaced volume of fluid, centroid of the horizontal projection of the body. So the line of action of the buoyant force acts through the centroid of the displaced volume of fluid. A body floats in stable equilibrium when its metacentric height is 0, when its center of gravity is below its center of buoyancy, when metacenter is above the center of gravity. So a body floats in stable equilibrium when metacenter is above the height of above the center of gravity. When a liquid rotates at a constant angular velocity about a vertical axis as a rigid body, the pressure intensity decreases as the square of the radial distance increases linearly as the radial distance varies inversely as the elevation along any vertical line varies as the square of the radial distance. So when a liquid rotates at a constant angular velocity about a vertical axis as a rigid body, the pressure intensity varies as the square of the radial distance. A right circular cylinder open at the top is filled with a liquid, specific gravity 1.2 and rotated about its vertical axis at such speed that half the liquid spills out. The pressure at the center of the bottom is 0, 1/4 its value when cylinder was full, one half if one half its value when cylinder was full, same as before rotation. So a right circular cylinder open at the top is filled with liquid, specific gravity 1.2 and rotated about its vertical axis at such speed that half the liquid spills out. The pressure at the center of the bottom is 0. Okay, a forced vertex turns in an opposite direction to a free vertex, has the velocity decreasing with the radius, occurs when fluid rotates as a solid, has the velocity decreasing inversely with the radius. So a forced vertex occurs when fluid rotates as a solid. A free vertex, now we'll see, a free vertex has the velocity decreasing with the radius, has the velocity increasing with the radius, has constant velocity, has the velocity varying inversely with the square of radius. So a free vertex has the velocity decreasing with the radius. Next, we'll continue. A control volume refers to a fixed region in space, a specified mass, a closed system, a reversible process. A control volume refers to a fixed region in space. One-dimensional flow is a steady uniform flow which neglects changes in a transverse direction, restricted to flow in a straight line. A one-dimensional flow is flow which neglects changes in a transverse direction. A practical example of steady non-uniform flow is given as motion of a river around bridge piers, steadily increasing flow through a pipe, steadily increasing flow through a reducing section, constant discharge through a long straight tapering pipe. A practical example of steady non-uniform flow is given as constant discharge through a long straight tapering pipe. Continuity equation expresses the relation between energy and work, relates the momentum per unit volume for 2 points on a streamline, relates mass rate of flow along a stream tube, constant discharge through a long straight tapering pipe. Continuity equation relates the mass rate of flow along a stream tube. Steady flow occurs when conditions do not change with the time at any point. Conditions are the same at adjacent points at any instant. When dou v by dou s is constant, conditions change steadily with the time. So steady flow occurs when conditions do not change with time at any point. Streamline. A streamline is the line connecting the midpoints of flow. Flow cross section is defined for uniform flow only. Is drawn normal to the velocity vector at every point, is fixed in space in steady flow. So a streamline is fixed in space in steady flow. Uniform flow occurs whenever the flow is steady, only when the velocity vector at any point remains constant. When dou v by dou t is everywhere 0, when dou v by dou s is 0. Okay. So that's all, friends, for today's class. I think today's class will be helpful for your exam preparation. Okay. If you are having any doubts, so